Hello everyone! Today's joke of the day is, what do you call a pig that does karate? Stay tuned to find out. Our learning target for today is, I can make a box and whisker plot to represent a set of data. Make a box and whisker plot with the following data. So we have this set of numbers, and in order to make a box and whisker plot, the first thing we want to do is order them from least to greatest. Okay, so I'm going to put these back in order from least to greatest. So we'll start with the lowest one, which is 8, and I'll cross them out as I go so I don't get confused. 8, and then 13, 14, 16. We have that one twice, so I'll write down 16 twice. 18 we also have twice. There are two 20s. Oops. I just wrote 22 instead of two 20s. Okay, two 20s, and then there is also a 22 and a 30. Okay, so now we are going to figure out some different points in this data set to help us create our box and whisker plot. Our minimum is going to be our lowest number, so that will be 8. Our maximum will be our highest number, which is 30. Okay, our median, that's going to be the one that's right in the middle. Okay, so I'm just going to go down the data set and cross off one number on the bottom and one on the top till we get to the middle. So if I cross off 8, I'll just put a little check mark, and then 30. 13, 22, 14, 20, 16, 20, 16, and 18, and we are left with 18, which means that 18 is going to be our median. That's the middle of our set of data. Okay? Then we want to find quartile 1, so the first quartile, and the third quartile. Okay, so that's the median of like the first half of data. That's quartile 1, Q1, is going to be the median of this first half of data. And quartile 3, that's going to be the median of the second half of data. We don't include the actual median. Okay, so now I'm going to go through and find Q1. So I'll cross off 8 with 16, 13 with 16, and then 14 is what I'm left with for Q1. And I'll put that right there. And I'll do the same thing with this other set of data, 18 and 30, 20 and 22, and we're left with 20, which will be our Q3. I'll write that in red as well. 20, which will be our Q3. Okay, now in order to make our box and whisker plot, we're going to use this number line, but we need to label what our data is. Okay, we need to label our number line, and so I'm going to we want to start with our minimum, so we have to go from 8 to 30. Okay, and I'll just go up by 2s, 12, 14. You'll always have to adjust this based on what your data is. And here I'll even gotta extend it a little bit and write 30 out there. Okay, so right now we have all of our data labeled. So we are going to put points or lines at each of these different points. Okay, so we'll put a dot at our minimum. I'll do this in blue here. Dot at our minimum. Okay, but we just draw this right above our number line. That's where we draw our box and whisker plot. So I'll put a dot at the minimum and one at the maximum. Okay, we'll put then a dot and a line here at our median. Okay, as well as at our quartile 3, our third quartile, and our first quartile, which is 14. Okay, so it's a box and whisker plot. So this is where we make our box. Okay, we connect these 3 lines. So we have our Q1. I'll even label this for us. Q1, this is the median, and this is Q3, and then this is the max, and this is the min. Okay, and then these become our whiskers for our box. So we draw those out like that. Okay, so what our box and whisker plot is saying is that we have our data is split into 4 sections, each of them worth 25% of our data. Okay, so if we have this part down here, okay, This half is 1/4 of our data, so that's 25% of our data. This box is 25% of our data. This box is 25% of our data. And then this long stem is another 25% of our data. Okay, and we'll talk about that a little bit later in the video when we talk about interpreting box and whisker plots. Okay, for now, let's just look at another example. Okay, if we're going to make a box and whisker plot with this data, we will start out by listing it from least to greatest. Okay, so we'll start with, I will change from back to the pen here. Start with 4. Then our next lowest number looks like 17. And then 19. And then we have 2 20s. 23. 24, 26, and finally 28. Okay, so we'll do the same thing we did in the first example. Our minimum will be 4, that's our smallest number. Our maximum is our biggest number, 28. For the median, we will just check off 4, 28, 17, 26, 19, 24, 20, 23, and then 20 becomes our median here. Okay, and now let's look at quartile 1 and quartile 3. Okay, so we'll find the middle of these data points. Well, we'll cross off 4 and 20, and then we're left with 17 and 19. And we want whatever number is right in between those. Okay, well, they're only one number apart, so it's really easy to figure out. It's going to be the number 18. Okay, but the way we would find that is we would do, if you didn't know what number was right in between it, you would do, you'd add your two numbers together, 19 plus 17, and then you divide by 2. Okay, so that's going to be 36 divided by 2, which is equal to 18. Okay, and that's how we figured that out, whatever number is right in between them. Okay, and then we'll do the same thing with this set of data. And right now, again, we're right in between 24 and 26, which we know is going to be 25. Okay, so now that we know those specific things about our set of data, we can make our box and whisker plot. Let's first label our number line. Okay, I'm going to go up by 4s here, so I'll go 0. Well, really each line will be 2, but I'll just write the ones by 4. 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. Okay. And then we'll make our box and whisker plot by plotting our minimum and our maximum. Our median is 20, so we'll really just make a line there. Our first quartile is 18, which is right in between 16 and 20. That'll be right here. And our third quartile is 25, so that'll be about right here. We'll draw those lines in, make our nice little box, and whiskers. Okay, so again, each of these sections, the whisker, the first box, the second box, and then the other whisker, contain 25% of our data. Okay, so the ones that are smaller have more data squished together. There's a higher concentration there. And then the ones that are further apart, there is a lower concentration of data in that 25% section. Okay. All right, now let's look at an example where we'll have to interpret a box and whisker plot. Okay. The incubation time in days of a canary, dove, myna, pigeon, parakeet, raven, chicken, cockatoo, peafowl, turkey, swan, and Muscovy duck are observed, and the plot has been drawn. So we're going to read the box and whisker plot and answer the questions. All right? Well, the first question is, what is the first quartile? Well, we are going to draw a line down from the first quartile here, and that's going to tell us what the first quartile is. So I'm going to say that Q1, right here, let's see, these each go up by 1, and it looks like it's kind of in between 15 and 16. So we're going to say that that is 15.5. Okay, then we'll look at the third quartile, Q3. Draw a line down here. Okay, that looks like that is going to be at 28. Right? Yep. Okay, And then we want to find the IQR, which stands for the interquartile range. So that's just going to be this range right in here. Okay, so not including the whiskers, just the box part of the box and whisker plot. Okay, the interquartile range we find by taking the third quartile minus the first quartile. So in this case, we're going to take 28 minus 15.5, and that is going to give us 12.5. So the IQR, or the interquartile range, is 12.5. Okay, now let's think about the median. Let's see, the median will be right here. Looks like it's about halfway between 20 and 21, so the median is going to be 20.5. And now, this question asks, what is the longest incubation time surveyed? Well, the longest incubation time, that'd be the biggest, the maximum. So that would be our maximum up here, which looks like it's about 35. And it's in days. Okay, our graph up here says in days. So it's going to be 35 days. Now, this question asks, is the data spread evenly or is it skewed in one direction? So remember how I talked about how each of these sections contains 25% of the data. So this contains 25%, this contains 25%, this contains 25%, and this contains 25%. And the longer the whisker or the bigger the box, right, the more spread apart the points are, like the median and the third quartile, for example, the less concentrated the data is, okay? So in this case, it looks like we have a higher concentration over here between the minimum and the median than we do between the median and the maximum. So we are actually going to say that this data is not evenly spread and it is skewed to the right. Now, skewed right means that we have a higher concentration on the left-hand side, so it's kind of distorted to the right. Okay, it's a little bit off. And so it's more spread out on the right side and not as concentrated. So we say that it is skewed in that direction, and that is kind of throwing it off. Maybe like there's an outlier or something like that over there. Okay, and then we want to look at the highest concentration of data points. Well, that's right here where we have the smallest range kind of between them, the smallest difference in between the minimum and the first quartile. So we'll say that it's the highest concentration is between the min and the first quartile, quartile 1. And this in context means that it is more likely that a randomly chosen bird will have a small incubation time or a lower incubation time. So it'll mean randomly chosen bird will have a lower incubation time. Okay, it's more likely that it will fall in that range, right? Now for today's joke of the day. What do you call a pig that does karate? A pork chop. Thanks for watching and have a great rest of your day.